All right, guys, this is the video for section 10.5, and in this section, we're really going to start getting into more formulas, and it's really going to get a lot more mathy from here on to the end of chapter 10. So I highly advise you to, as we end each night, maybe go over the formulas to help remember them. There is a pattern, so it's not just a bunch of random formulas, but there are some differences in each of them, so just make sure you're not trying to cram and learn them all the night before the test, because that won't work. All right, so before we get into this, we need to go over a single vocab word, and it's a circumscribed angle. Okay, now this picture down here, this is a circumscribed angle. Okay, it's basically an angle that is tangent to the circle at 2 points. Okay, so an angle whose sides are tangent to a circle, and because the sides are tangent to the circle, it has to be located outside of the circle. Okay, so like I said, down highlighted here in yellow is a circumscribed angle. All right, so let's look at this first theorem. So theorem 1014, tangent and intersected chord theorem. Okay, so this theorem tells us that if a tangent and a chord intersect at a point on the circle, okay, that's kind of the key here, then the measure of each angle formed is 1/2 the measure of the intersected arc. Okay, so if angle 2 is x, the intercepted arc here would be 2x. Okay, and likewise, if the measure of angle 1 is y, the measure of this would be 2y. So this is kind of like an inscribed angle, which really it is an inscribed angle, except the other line isn't here. Okay. So let's look at an example here. All right, so down here says line M is tangent to the circle. Find the measure of the red arc or angle. Okay, so in part A, we're looking for the measure of angle 1. And if this intercepted arc here that's given is 130 degrees, angle 1 has to be half that. Okay, so it'd be 1/2 of 130, which is, I believe, 65 degrees. Okay, so angle 1 has to be 65 degrees. Now, if I wanted to go further, which I know we don't have to, if this angle 1 is 65 degrees, then this angle right here, these two have to be supplementary, so this one would have to be 115. Okay, and this arc here would be double that, which would be 230. Now, a good way to check yourself, you know, these have to be supplementary, and adding this and this would go all the way around the circle. So if you add it, it would equal to 360. I know we did a little more than we needed to, but it does all work out. All right, go ahead and try to do B on your own. B wants to know the measure of this arc here, knowing that this angle is 125. All right, so you should have known the intercepted arc is double what the angle was. So if the angle is 125, you multiply that by 2, you should get 250 degrees. All right, guys, so this is kind of a concept that you need to understand, and it's not hard. So it just says if two non-parallel lines intersect a circle, so two lines intersect, there are 3 places where they can intersect. Okay, they can intersect on the circle. So you'd have this figure here. So these would intersect at this point, which is on the circle. They could intersect inside the circle, which you'd have this here. So this point of intersection is inside. Or they can intersect outside the circle, and therefore it'd be outside. Okay, now these can look a lot different within themselves, but they have to intersect either on the circle, inside the circle, or outside the circle, and depending on where they intersect depends on which equation you would use to find things. All right, let's look at this first one here because we have already covered it. If these two chords or if these two secants intersect on the circle, okay, this would be an inscribed angle. Okay, and remember, an inscribed angle is half the measure of the intersected arc. So if this is angle x, then this would be 2x. Okay, we've already learned that. You should know that. Now we're going to learn formulas for these two scenarios here. All right, so here are some more formulas, guys. Now, this can get overwhelming, I know. So angles inside the circle theorem. So if two chords intersect on the inside of the theorem, like we just said, anywhere on the inside, we would use these formulas, okay? So it says if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, this is the same thing as saying it's the average of the two intercepted arc. Okay, so angle 1 would be 1/2 DC plus AB, or the average of arc DC and arc AB. And then angle 2 would be the average of AD and BC. Okay, now if the circles are outside, so they can look very different, but it doesn't matter. They intersect outside. Here they intersect at this point, this point, this point, doesn't matter. The formula you use is the same. Okay, so it's the same as this formula, but here we're subtracting the intercepted arcs, okay? And it's going to be the outside arc minus the inside arc. Or you could do the big minus the little, okay? That's what's in parentheses here. And you're still going to multiply it by 1/2. All right, this will make more sense after we do a couple of examples, so let's get to the examples. All right, so on part A, this is example 2. So part A on example 2, we want to find the measure of x. So if we find x and its vertical angle would be right here, okay? We want the intercepted arc of those two angles. So it'd be this angle and this angle. Those would be the intercepted arc. Now, because we are intersecting on the inside of the circle, we would use the plus formula, okay? Anytime we're inside the circle, we'd use the plus formula. So the measure of angle x is going to equal 1/2 times the sum of these two arcs. So 130 plus 156, or 1/2 times, what is that, 286, which is 143 degrees. All right, now let's look at this one over here. Now here, the first thing we want to recognize is these two intersect outside of the circle. So we're going to use this same formula, except this is going to be a minus sign. Okay, so this angle is going to be 1/2, and you want the two intercepted arcs. Well, this would be one of the intercepted arcs, the big minus the little, or the outside minus the inside. Let me do these in different colors because they do kind of exchange hands there at D. Okay, so here I would say that x equals 1/2. Now remember, this is outside of the circle, so this plus is going to be a minus. So it'd be 178 minus 76, or just 1/2 times 102. So x then would be 51. All right, I want you to try to do these two on your own. Use the same formula, just what you have is a little different than what we had before. And we will go over these pretty much in depth, but I want you to go ahead and try them. Now recognize that you have this intercepted arc and this intercepted arc, but you have this angle here. Okay, so ask yourself, how could you get this angle? Okay, so I'm going to give you a minute, try these on your own, and then we'll go over them. All right, let's go over these. If you didn't get these, that's okay. These are a little bit different. Same formula, just a little different than what we've done. All right, so if this is 102, guys, then this here has to be 78 because these are linear pairs. Okay, now this angle here and its vertical angle will go with these two intercepted arcs highlighted. And because we are intersecting on the inside of the circle, we would use the angle equals 1/2 the addition of the two intercepted arcs. Okay, that's kind of a sloppy way to write it, but I did. Okay, here we know the angle. The angle is 78, so I'm going to say 78 equals 1/2. And the two intercepted arcs of this and its vertical angle would be 95 and y. Okay, now most of you guys are going to want to distribute this right away, which isn't wrong. You're just making your life a little bit harder. So rather than distribute it, let's multiply both sides by 2. Okay, and when you divide by 2, 1/2 times 2 is just 1, so those would cancel out. Okay, so 2 times 78 is 156 equals, you're just left with 95 plus y. So subtract 95, subtract 95, you'd be left with 61 equals y. Okay, so this here would be 61 degrees. And once again, we add these because it intersects at the inside of the circle. Okay, now over here, we're intersecting outside of the circle. So it'd be angle equals 1/2 arc minus arc. And it's a minus because once again, we're outside the circle where these intersect. Okay, so we're going to intersect the big arc or the outside arc minus the little arc. Okay, so I'm going to go ahead and highlight. So here's the angle, and the two intercepted arcs are here and here. Okay, so if I plug stuff in, the angle, which I know the angle, it's 30 degrees, is going to equal 1/2. The big arc is A minus the little arc is 44. Okay, so that's how we would set it up. Okay, now I've taken a geometry problem, turned it into an algebra problem. So once again, rather than distribute this, which isn't wrong, you're just making your life a little harder, I'm just going to multiply both sides by 2. Okay, because 1/2 times 2 makes just 1. So essentially those cancel each other out. And 2 times 30 is 60 equals A minus 44. Okay, now we're almost there, so let's add 44 to both sides. You get 104 equals A. We are all done with that problem.